Hello again in the course of the data structure and algorithms. For this video, I will continue with the lecture that we already had before. And this chapter actually is related more on the graphs. If you are using the book that I recommend to you, which is about data structures and algorithms in Python, so you need to check the book in chapter 14. Okay, I guess I need to go to this chapter first because it is more related to the industrial engineering field, and I hope that my explanation on this section will help you to think more about what you're going to do in your team project. I try to read some of the proposal from the team project. However, yeah, I guess there are still rooms for improvement, and I'm expecting you to improve those proposals in some weeks later. Yeah, I will give you some feedbacks after I complete all the things. So before doing the feedback, yeah, I will check more about your proposal. I will send those feedback into the e-class in your account. Okay, so I will let you know with the announcement about the feedback. And now let's try to understand the concept of graph. So in this chapter, we are going to learn about the graph and the terminologies and the graph ADD and the implementation in Python code. So what is graph? Yeah, we will check the graph in this chapter. In the basic concept of graphs, it is a pair. Okay? It is a pair of V and E. What is V? What is E? So V, it is the node. Okay? So we call it nodes or vertices. So when we deal with the nodes or vertices, it means, yeah, like this one, SFO, ORD, PVD, okay. So we can say that it is node, okay. This is node, this is node. And we have also E. E is a collection of pairs of vertices, or we call it edges. Okay? So it is vertices to indicate V, and then edges is to indicate E. Okay? So the vertices is the SFO, HNL, LAX. What about the edges? The edges means the connection between these two. So what is HNL, LAX? So this is an example about the airport. Okay, if you know airport, like say this is the airport in the US. Okay, so we have Honolulu, LAX is the Los Angeles, SFO is San Francisco, yeah, and yeah, DFW I think is Dallas, okay, and ORD is Ohio, Detroit, okay, and so on. Okay, Miami and Pennsylvania. So those airports are indicating the airport, okay, the nodes indicating the airport, but the edges indicating that we have an airplane or we have a route for the trip from Honolulu to LAX, and we have a trip from the LAX to San Francisco, and so on. So in this data structure, we can say that the vertices are positioned and the edges, yeah, also the position, and it stores the elements. Okay? So we will see more examples later about how we can do with graph. So in this example, the vertex represent the airport and stores three-letter airport code, and the edge represent a flight route, okay, between the two airports, and it stores the mileage of the route. So the mileage means this one. In this case, the mileage is 2555. So it means 2,555 miles away from Honolulu to Los Angeles. First, before we go through the details of graph, we need to understand some of the basic type of graph based on the edge. Yeah. So first, we will have the graph, which is a directed edge. A directed edge means it is an order pair of vertices. Okay, order pair of vertices. What does it mean? We order pair. So in this case, we have the direction. Okay, so you can see there is the direction here. The direction means I have a flight. This is AA 1206. It is a flight from O'Hare, Detroit to the Pennsylvania. So this A is one direct flight. But if you want to know another direct flight, then it means like this one. You will have another direct. So we call this is the directed edge because we have the first vertex, which is U, is the origin, and the other vertex, which is the second vertex, which is V, is the destination. Okay, so if you have like a supply chain, you want to send the product from manufacturing to the customer, then the manufacturing will be the U or the origin, and the customer will be the destination. So you can put that one as a directed edge. There is another kind of graph, we call it undirected edge. Okay, the undirected edge means it is an unordered pair of vertices. It means we have two vertices, ORD and PVD, and yeah, there is no direction. It means, yeah, we just want to know that between the ORD and PVD, the distance is 849 miles. Okay? And it is regarded from ORD or PVD to RD. Okay? So it is just a flight route. We can say the graph, okay, in the respective of the graph, because this is the directed graph. It means all the edges are directed. So if we have like the node like this one, okay, so if all we have this directed, and then we have another node, this is directed. Then if all edges are directed, we call it this is a directed graph. But we can call it as undirected graph if all the edges are undirected. So some of the graph may have both directed and undirected edge. Okay, so yeah, it depends on what you're going to do, but basically this is the definition of the graph based on the edge types. And the application can be anything. Okay, maybe in the previous example, it's just only to show about the route, but you can also deal with the graph for the electronic circuits. What is electronic circuits? Yeah, you can know the line between one circuit to another circuit. So it is the printed circuit board. Or in the integrated circuit is also a connected line between one component to another component. We can also use the transportation networks, okay, like the highway networks and flight networks. Okay, so those kind of networks, it can be represented by graph. And this domain actually is very important in the industrial engineering. So I'm expecting that your team project will be related with the transportation network, or yeah, something related with the industry like the warehouse, or yeah, if you can deal something with the data analysis, that is also fine. Yeah, as long as it is related to the industrial engineering. And as I mentioned to you, so if you can deal with some algorithms dealing with COVID-19, that will be also better. It can be also related with the computer networks. For example, you have the LAN, local area network. If the cable is connected to one computer to another computer, then you can make a network as well. Internet, web. Okay, so those kind of networks can be also used, or it can be also drawn with the graph. And database, yeah, if you learn database before, you can see the entity relationship diagram. So that's one concept in the database, and you can use graph to show the relationship between the entity. In the graph itself, we also have some terminology. Okay, what is the terminology? First is we need to understand about the end vertices, okay, or endpoints. The end vertices means, yeah, everything when you have node, then it can be the endpoints. So you have the U and you have the V. Okay? They are the endpoints of A, because we are checking the edge. Okay, so we are checking the edge. The second one is the edge incidence on a vertex. What is edge incident on a vertex? So let's see, we have V. Okay, so we have V as the V is the vertex, and then we have the edges incident is A, D, and B. With small a, and so this one A, and then we have D, and then we have B. Okay, how about the adjacent vertices? So the adjacent vertices means we want to know two nodes, two vertex which is adjacent or which is in the nearby, and it is connected with an edge. So for example, this was U and V. Okay, so U and W is also adjacent because we have a line C. Okay? V and W is also an adjacent because it is connected with the D. Okay? Degree of a vertex. Degree of a vertex we can check from the number of edges is connected. Okay, so for example, I can just use the okay, let me just erase this one to show you better way. Okay, so if we have the x, okay, x here is the vertex x, and what is the degree? So the degree is we have 1, we have 2, we have 3, we have 4, and we have 5. So there are 5 edges that is connected to one vertex. So the degree is 5 for the vertex x. What about if it is the vertex v? We have 1, we have 2, and we have 3. So there are 3 degrees. Okay. The parallel edges. Parallel edges means they are connected to the same vertex in both of the edges. So if it is H and I, okay, so they are the parallel vertex. Okay, so this H and I are the parallel vertexes, parallel edges. Okay, sorry. So if you have also the self loop, okay, so self loop is also another kind of terminology in graph. So J is the self loop. The node Z will have a node which will have an edge which is connected to its node. Okay, so those kind of definition or the terminology you should remember. And there is another kind of terminology which is path, simple path and cycle. So we can learn about that one. So what is path? A path is a sequence of alternating vertices and edges. So we have P, yeah, sorry. Okay, I will just explain this one. So the path will begin with a vertex and path will ends with a vertex, and each edge is preceded and followed by its endpoint. Okay. If it is a simple path, it means it is a path such that all its vertices and edges are distinct. Okay. So the key point is distinct. Distinct, you know, distinct is unique. So there will be no repetition on the edges and the vertices. Let's see. You have P1. Okay, the P1 is this from V, okay, and then it goes to the HB, and then it goes to the vertex X, and this going to the HH, and then it goes to the vertex Z. So this one is a simple path because there are vertices and edges, and they are distinct. This is not repeated. But what about the path is which is not simple? We have P2. Okay, the P2 it starts from U, and then it goes to C, and then it goes to W. Okay, it goes to W, and then it goes to E, and then it goes to X. It goes to G, and then Y, and then F, and then W, and then D, and then V. Okay, now you can see this is a path, but it is not simple. Why? Because we can see W and W. So W has been repeated at least more than one time. So this, because of this one, then we can say that this is a path which is not simple. What about cycle? Cycle is a circular sequence of alternating vertices and edges. The edge is preceded and followed by its endpoints. Simple cycle means with all vertices and edges are distinct. So the same with the simple path. So let's see the simple cycle is C1. Okay, so we always have the endpoint to the vertex, the origin vertex, but we will not represent it as a vertex in the endpoint. So let's see. If we start from V, okay, if we start from V, we have the C1. So we go to B, which is the X, and then go to G, and then this the Y, and then we go to F, and then we go to W, and then we go to C, we go to U, and then we go to A, and return back to V. Okay, so the representation of the last vertex or the endpoint is just giving the cycle symbol. So we call this is a simple cycle because there is no same vertices and edges. What about C2? So in the C2, we want to start from U. Okay, let me just delete first. Okay. So we can also deal with the cycle from U. Okay, and then we go to C, and then we go to W, and then we go to E, we go to X, and then we go to G, and then we go to Y, and then we go to F, we go to W, and then we go to D, and then we go to V, and then we through A, go back to U. Okay, so if we have this cycle, then it is a cycle which is not simple. Okay, it is not simple. There are some properties that you need to understand about the graph. Okay. We have n, we have m. N indicates the number of vertices, and m indicates the number of edges. And whenever we have the vertices and edges, we can calculate the degree. Okay, so the degree of v, it means the number of edges that is connected to that vertex. There are two properties that we can understand from the graph, which is the property one about the number of edges is the same of the degree of v, and we can sum all the degree of v. The property two, it is an undirected graph with no self loop and no multiple edges. Okay, so you know the no self loop. Okay, so there is no vertex, there is no edge that is going to the same vertex, and there is no multiple edges. It means there is no parallel. Okay, so prove each vertex has degree at most n minus 1. Okay, so this is for the undirected graph. Let's see if you have these properties. Okay, so the degree of v plus so the summation of all the degree of v equals to 2 multiplied by m. So let's say this one we have v, so this one is 3, we have 3, 3, and 3. Okay, so it means 3, okay, plus 3, and then plus 3, and then plus 3. It will be equal to 2 multiplied by m. M is the number of edges, so we have 1, 2, 3, 4, 5. Oh, sorry. 1, 2, 3, 4, 5, 6. Okay, there are 6, so it means we have 2 multiplied by 6, which is the same with the 3 plus 3 plus 3 plus 3. Okay, so it's 12. What about the second properties? So the second properties is an undirected graph. So we will have the m, which is less than n multiplied by n minus 1 divided by 2. So in this case, we have n equals to 4. Okay, 4 multiplied by 3 divided by 2, it means 6. Okay, it should be less than or equal to m. M it is 6. Okay, so it's, yeah, it satisfies the property. What about the bound for a directed graph? Okay, so yeah, basically the directed graph will be the same. Okay, if you have this one, if you have this one, yeah, but of course if you have the other way around, yeah, there might be some boundaries for the properties. So these properties is for the undirected graph. For the directed graph, there will be another properties. So in the graph, as I mentioned before, it is a collection of vertices and edges. And when we model the abstraction as the combination of 3 data type, okay, so we will have vertex, we will have edge, and we will have graph. And a vertex is a lightweight object that stores an arbitrary element provided by the user. So for example, you know, the airport code. Okay? So we will assume that it supports the method, element, and how to retrieve the stored element. The edge is something which is associated with the object. Okay? So it means we have a flight number or the travel distance or cost, and it will also retrieve from the perspective of the element. In addition, we assume that edge supports the following method. We have the endpoints and opposite. So what does it mean? The endpoints, it means we have a tuple u and v such that the vertex u is the origin of the edge and the vertex v is the destination. So for an undirected graph, the orientation is arbitrary. So if I want to know a tuple u and v, okay, so the endpoints will be, if I know the u is the origin, then the v will be the destination. So that will be the endpoint. What about the opposite? The opposite means if I know that vertex v is one endpoint, then the other endpoint will be the opposite. Okay. There are some graph ADD. For example, the vertex count. I want to know how many vertices in the graph. And then vertex, it means I want to iterate. So I want to loop for every vertex in the graph. Edge count, I want to know the number of edges in the graph. Edges, so I want to iterate for every the graph. Get edge, so it will return the edge from the vertex u and v if it exists. But if there is no existing edge, then it will return none. For undirected graph, there is no difference between get edge uv and get edge vu. Okay, for undirected graph, the order is not a matter. If you want to know the degree v out true, so it means I want to know if the undirected graph, it will give you the number of edges incident to a vertex v. So I want to know how many edges incident to the vertex v. Incident edges v are true. So this is I want to know how many all edges incident to the vertex v. So if it is the degree, it means I just want to know the numbers. But if it is the incident edges, I want to know the iteration. I want to go to every edges. So I want to iterate. So it is the same like the for loop. Okay. Maybe I want to go to every edges for each of the edges. Okay. So it means I will go iterate to h1, h2, h3, and so on. I can insert a vertex. I can insert the edge. So it means u and v is two nodes and two vertices. Yeah, two vertices are connected to each other. I can also remove the vertex and I can remove the edge. Those are the basic graph ADD. So in the graph, you can deal with the data structure. For example, if you are using the edge list structure. What is edge list structure? Let's say we have the vertex object. The vertex object is the element, and it will be a reference to position in a vertex sequence. Edge object is the element, and the origin vertex object and the destination vertex objects, and there is a reference to position in edge sequence. We can do with the vertex sequence, and also we can do with the edge sequence. Okay, so let's see. Like this one, in the vertex object, yeah, we have the V, this one, okay, and the edge object we have the V, the E. Okay, so let's suppose we have this graph. Okay, this is the example. Okay, so we have the V, U, W, and Z. Okay, now if I have the following vertex object and edge object, I would like to put the V, okay, the V, U, W, and Z into the V. Okay, so you can see this one U and V and W and Z. Okay, now I have the edge which is E, G, F, and H, and those are the element in the edge. So E, F, G, and H. Now I want to know where is the E. Okay, where is the E? E is in between U and V. So I will make a line to U and V. What about the G? G is an edge which is between a U and W. So G is between the U and W. What about F? F is an edge between V and W. What about H? H is an edge between W and Z. Okay, so the relationship will be something like this one. So we call this is the edge list structure. We can make another kind of list structure using the adjacency list structure. In the adjacency list structure, we just use the vertex, and then we will just augment the edge objects. Okay, let's say we have the same graph like this one, but we just have only V, and then we just put the U and V and W and Z, which is the vertices, and for every vertices we put the uh, incident edges. So let's say U, we will have E and G, so we put E and G. What about V? V, we have E and F. What about W? W, we have we have F, we have G, and then we have H. What about Z? We have only H. Okay, so we call this is the adjacency list structure. We can also make this the graph into adjacency matrix structure. What is adjacency matrix structure? It is an edge list structure, and it will augment the vertex objects, and it is a kind of array, two-dimensional array, and we call it the two-dimensional array adjacency array. So the augmented vertex object will be the integer key associated with vertex, and the two-dimensional array, it will be a reference to edge object for adjacent vertices, and it will be null if there is no non-adjacent vertices. Okay. Oops, I guess I close this one. Oh yeah. The old version is just have 0 and 1. Okay, so if it is 0, it means we have no edge, and if it is 1, it is we have an edge. But yeah, there's another version for creating the adjacency matrix structure, like this one. We have the same graph, and let's say we have the U as 0, we have V as 1, and then we have W as 2, and then we have Z as 3. Okay, so the same U 0, 1, 2, 3. Now we want to go to the details, the relationship between each of the vertex. So 0 and 1. So it means U and V. U and V, there is an edge which is E. So we write E here. What about U and W? U and W, we have the edge G. Okay, so we write G here. What about V and W? Okay, V and W, so it means 1 and 2. We put the F here. What about E? E here is the relationship between U and V. Okay, because U and V and U, so there it is an undirected graph, so you can put E in two cells. Okay, so you can put E here and you can put E here. The same with the other, which is G and then H. Okay, so it means it is a kind of matrix. You can represent the graph in terms of the matrix. For the performance, I think the space, okay, the space is just the n plus m. It means n, it means the vertices, okay, and m, oh sorry, n is the vertices and m is the edges. Okay. And we assume that there is no parallel edges and there is no self loop. So if there is no parallel edges and there is no self loop, so you can get the space is n plus m. And then we have the adjacency list, okay, is s n plus m. For the adjacency matrix, we have n power of 2. So which one is better? Okay, so of course you need to choose the edge list or adjacency list, which is smaller than adjacency matrix. But when you do the edge list and adjacency list, it will be more complex in the term of the programming, of course. So this is the things that we already learned in the first part of our course about the data structure. Incident edges. So if you are dealing with the incident edges, you want to know the incident edges of V. And when you want to know the incident edges of V, the edge list will take M, and the adjacency list will have degree V, and the adjacency matrix will just do at N. Okay. Then R adjacent. So I want to know if V and W is adjacent or not. Then you can just use M times for the edge list. And if you are using the adjacency list, it means the degree of V and the degree of W, and you will get the minimum. Yeah. And then the one means, yeah, just one time, because it's easy. With the matrix, you can just choose the particular uh, node and the other particular node, and then you will have only one operation. What about if you want to insert a vertex? So if you want to insert a vertex in the edge list, you will have just one. And if you are in adjacency list, you will also have one operation. But for the adjacency matrix, you will have n square. Yeah, because when you have the new vertex, you need to indicate whether there is an edge or not, and then you need to check what is the connection between the other node. When you insert an edge, okay, so the edge list just take one, the adjacency list just take one, and how about the adjacency matrix is also one. Okay, because you know that there is already V and W, so you just want to put it into the cell, then just one for the adjacency matrix. If you are removing, okay, it will take m times for the edge list. It will have degree of V for adjacency list, and it will be n power of 2 for adjacency matrix. But if you are just giving up the edge, okay, so you want to remove the edge, so it will just consume 1, 1, and 1. Okay. For the Python graph implementation, we can use the adjacency map representation. So I hope that you still remember the map section. Okay. And for its vertex V, we use the Python dictionary to represent the secondary incidence map, IV. And the list V is replaced by a top-level dictionary that maps its vertex to its incident map, IV. So we can iterate all through the vertex by generating the set of key for dictionary D. So if you know the V for the dictionary, then you can just indicate what is the, yeah, it is just indicating the node. Okay, V is the key and the values are the adds. A vertex does not need to explicitly maintain a reference to its position D because it can be determined O1 expected time. Okay. So running time bounds for the adjacency list graph. Okay. So in this case, we are using the adjacency list. So yeah, it will become unexpected bounds because okay, if we have the v, and then yeah, the v, and if we have the value, the value will be added into more edges if the edges is more than 2, for example. And this is the case of the adjacency list. Okay, so I guess you still remember the adjacency list here. So this is the key and those other values. This is the key and those other values. This is the key, those other values, and this is the key and those other values. Okay, so we can use the dictionary to adopt with the adjacent list. This is the class. Okay, I think I will not explain the details of this code. By now, I'm expecting that you already learn what is the code in Python and you understand all the codes. So I will just give you all the Python code and you can learn by yourself. Anything that you need to ask, then you can just send an email. And I hope that you can use those graph. Okay, I'm expecting you to use this one for your team project, because I know there are some teams who have not decided about your topic. Okay? So the graph is one of the most important data structure in the field of industrial engineering. So I hope that you can use this one as your topic for your team project. Okay, I guess I think I will stop here and I will continue with the other section in another video. So thank you very much for listening.